So these notes are just to remind you guys of some of the important things about quadratics that you learned and practiced that will still be true and we will still use for other polynomials as well. So first of all, if you're given just a random general quadratic, no numbers in it, yes, it's a polynomial, because remember it doesn't have any variables in the denominator and no variables in a radical. It's got a degree of 2. And it changes direction one time, meaning that if it's a parabola that opens up, it starts out going down and turns around and goes back up. If it's a parabola that opens down, then it starts out going up and turns around and goes back down. So there's one direction change. The leading term is ax squared, and the leading coefficient is a. And so what you guys were taught is that if a was positive, it opens up, but that's actually the result of two things. When a is positive, it means that the right end goes up. That's true of all polynomials, and we're going to talk about that again. The reason that the left end also goes up is because of the degree. When the degree is even, because this is 2, the left end will go in the same direction as the right end. And once again, we're going to talk about that again. Okay. Well, you were also taught that when a was negative, that means that it opens down. But once again, really that's the result of two things. When a is negative, it really just controls the right end and makes it go down. Oops. And then, because it's got an even degree of 2, the left end will go in the same direction. So the result is, yes, it opens down, but that's not just because of a. The zeros, you notice that I didn't put any numbers in this equation, so I'm just looking for the abstract version of the quadratic formula. And I might have been inclined to sing the song for you, but you can hear how sick I am, so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There are no undefined values because it is a polynomial. And if your quadratic can be factored, because not all of them can be, obviously, but if it can be, there's going to be 2 factors. And that's because it's related to the degree of the polynomial. You can break it up into 2 linear factors if it can be factored. Okay? If not, what you'll have is technically one factor that's just a quadratic, and then you would have to find another way to solve that. The number of potential solutions to a quadratic, you guys saw 3 different situations. You had quadratics with no solution, and so those were the parabolas that started out above the x-axis and opened up. So they might have looked like that. Or it could have also been something like down here. Could have started out below the x-axis and opened down. So there are 0 solutions for that. You saw times when your parabola only had 1 solution. We're actually going to look at that again here in just a second. And those were the ones where your parabola did this, where the vertex was your x-intercept, and this is what we call being tangent to the x-axis or touching the x-axis, and we're going to talk about why that happens here in just a minute. And then the more common results were that you had 2 solutions because you do have a quadratic, it's got a degree of 2, and so that meant that your parabola went straight across the x-axis twice. So that's the more common situation. So take a quick second. This is a factorable quadratic. So take a second and factor it. Okay. Hopefully it broke up pretty easily for you. Factors as x plus 2. I don't know how to get rid of this thing. I'm going to jump over here. times x plus 2. And so what you get is you get x equals -2, but you get x equals -2 for both factors. So that solution occurs twice. And so graphically what this would have been is it's the same thing as x plus 2 squared. So it's just your parent quadratic shifted 2 units to the left. And so the vertex is the x-intercept. Okay, and what your graph is doing is it's being tangent to the x-axis. You don't have to say that. There's another way of saying it. It's a much simpler way, more of a layperson's way. It's bouncing off the axis. Or it's touching and turning around, however you wanted to say that. But your graph is turning around right at that point. It touches the x-axis there, but it doesn't actually go across it. And we're going to talk about that again actually tomorrow in class, Friday in class. This quadratic is not factorable, so I want you to pause the video. I want you to take a minute and I want you to do the quadratic formula and see what you get for the solutions. And then I'll pick up about halfway through the quadratic formula and make sure that you finished getting the correct answers. Okay, so hopefully you paused it, and hopefully you've already got complete answers. I just want to make sure everybody ended up at the right place. When you plug in the numbers into -b plus or minus the square root, then b gets squared, minus 4ac all over 2a, what you end up with is positive 4 plus or minus the square root of -36. And so you're going to need to remember some imaginary numbers. So the square root of 36 is 6, but the fact that it's negative makes it imaginary. And then the whole thing is still over 2, but both parts of this numerator are divisible by 2, so I can reduce it. So what you should have ended up with is 2 plus or minus 3i. There's your two answers. So your first answer is 2 plus 3i, and your second answer is 2 minus 3i. And this is kind of an ambiguous question, I know that, but what I'm looking for is when you looked at the original equation, there were no imaginary numbers in it. And so there's no way to just look at an equation and know if it's going to end up with complex or imaginary solutions. So there were no i's in it. And there's a reason for that. We're going to talk about that not until much later in our polynomial unit, but this is something you've seen before. These two particular solutions are called conjugates of each other. And we've dealt with conjugates before this year, but conjugates means that each of these is a binomial. It's got two terms in it. They're identical to each other except for the sign in between. One of them has a plus in between and one of them has a minus in between, because we dealt with conjugates back in trig and that kind of stuff. So we'll see that again later in this unit as well. And then the final two types of problems are ones where you wrote equations. Those are the ones we're going to be using most recently. So you had two different versions of your quadratic equations that you started out with. You started out with intercept form. Sometimes, depending on your teacher or book, sometimes they called this a P and a Q, but it means the same thing. It was x minus your first root, x minus your second root. The other version that you used was also vertex form, where h and k were your vertex. And both equations had the same a value out in front. And which version of the equation you used depended on what information you were given in the word problem. So if we look at this first example, it says write the equation of the quadratic, and here's a key word, the, meaning there's only going to be one correct specific answer. And it's going to be a quadratic, and it says roots at -2 and 6. So as soon as you see that, you know you're going to be writing intercept form or root form. And it tells you another point to go through, because the fact that we have to find the quadratic or a specific equation means we actually have to calculate an a value. So you guys started these problems out by plugging in the information you've been given. So we were given intercepts. We're going to plug in our intercepts. So if negative 2 is our first intercept, then x plus 2 is the factor. And if 6 is the intercept, then x minus 6 is the factor. And then the next thing that we did was we took this x and this y, and we plugged it into our equation to solve for a. So I'm going to put the 6 in there for the y, and I'm going to put the 4 in there for the 2, or for the x, sorry. And so I have 6 is equal to a times 4 plus 2 is 6, and 4 minus 6 is negative 2. So I have 6 is equal to negative 12 times a. And so that meant that a was negative 1/2. So our equation, our completed intercept form, our a value is negative 1/2, and we already knew our factors were x plus 2 and x minus 6. Now we're going to be multiplying all of our equations out, so we may as well go ahead and start now. And so what we would do first is we would FOIL these two binomials together, and we would get x squared minus 4x minus 12. And then we would distribute the negative 1/2 through there. And so our final answer would be negative 1/2 x squared plus 2x plus 6. There's the standard form for our quadratic. Okay, and then the final example, I want you guys to take one of those two quadratic versions, and I want you to take it as far as you can. Try and write the specific quadratic equation, see if you can get it all the way, or at least figure out which version of the equation you're going to start out with and get it started. Okay, so hopefully you figured out that the minimum point meant you'd been given the vertex, so you were going to use vertex form. Then hopefully you also remembered that vertex form says x minus h, so there's a sign change in there, and plus k, so that means the 7 has a sign change but the negative 3 doesn't. And then you should have plugged in the x and the y that you were given. Now I'm going to do two steps at once, and hopefully I don't lose anybody. These two things are attached to each other, and there are quite a few people who like to attach this minus 3 here as well, so I'm just going to go ahead and I'm going to move it to the other side. I'm going to add it to move it over so that it doesn't accidentally combine with the a times that number. And then 9 minus 7 is 2, and then squared is 4, so it's a times 4. And so that means that my a value is 3/4. So my vertex form is y equals 3/4 x minus 7 squared minus 3. Okay, now remember, we're not going to leave our equations not multiplied out, but also there's no vertex form for cubics and for most quartics, so we're going to go ahead and multiply it out anyway. So we have 3/4 x minus 7 squared would be x squared minus 14x plus 49. Then we distribute the 3/4 through there. So 3/4 x squared minus, you can take that 3/4 times 14 and you can multiply it and then reduce it, or you could go ahead and reduce it, and a 2 will reduce out of each thing, so that would make that a 7 and make that a 2, and so you would have 21 over 2x, and then 3/4 times 49, 20, so what, 147 over 4, and then we still have to subtract the 3, but I'm going to go ahead and I'm going to write it as 12 over 4 so that it can combine to the other constant. So y equals 3/4 x squared minus 21 halves x plus 1/35. There's our standard form. Kind of messy, but that's okay. We don't mind messy. So that's it for tonight. Make sure that you remember a lot of these skills when we start applying the same process to cubics and quartics. And feel free to come in for tutoring if you need help.